there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, chapter 11.1 is utility expenses. So let's go over the definitions real quickly. Utilities are just simply what you use in your house or apartment, and they include electricity, natural gas, heating oil, water, that kind of thing. Those are utilities. Now, a meter is simply a device that records how much you use. How much water do you use? There's a water meter. How much gas do you use? There's a gas meter. Electricity, there's a meter for that, and so on. Okay. Watts. Electricity is measured in watts. That's the unit of measurement for electricity, watts. Kilowatt hour. Well, kilo means 1,000. So 1,000 watt hours. So if you think about kilowatt hour, if you had a 100 watt bulb burning for 10 hours straight, that would be 1,000 watts, which equals 1 kilowatt hour. Okay, does that make sense? 100 watt bulb burning for 10 hours equals 1 kilo, 1,000 watts, 1,000 kilowatts. So it would be a kilowatt hour. All right. Cubic foot, well, that's just simply a volume measurement, cubic foot. And let's see, so here's a cube. So if this side was 1 foot length and the width was 1 foot, or our base was 1 by 1 and our height was 1 foot, then this is 1 cubic foot. Volume is just simply length times width times height when you're dealing with a cube. If it's a different shape, it's your base area times your height, etc. And CCF. CCF is 100 cubic feet. So CF would be cubic foot, and they're using C for 100 because Latin, or like in Italian, 100 is cento. So C, 100, cento, 100 cubic feet. Latin is probably derived from Latin. Okay, so C, just think of that as 100. Or if you're in the medical field, a C would be 100. Okay, and then therms, the last thing is a therm. What did they say about therms? When you're billed for your natural gas usage, the units are often reported in therms. So it's a natural gas usage. Okay, and so that's the definition. So let me just clean this up a little bit and we'll get right into example 1. So Tom's October water bill listed 2 meter readings. Okay, so you got a bill, you got a previous reading, and it was 3,128 CCFs, or 100 cubic feet. And the present reading is, so previous, and then you have present. So we'll put the present above 3,141 CCF. How much water did Tom's household use during the billing period? So all you do is you take the present, you subtract the previous, and you are going to get 1 minus 8. 11 minus 8 is 3. 3 minus 2 is 100. So they used 13 cubic feet. 1,300 cubic feet, 13 CCFs were used during the period of October. Okay. Okay, so now the check your understanding says Ron used X CCF of water during a summer month. Express the number of cubic feet of water he used algebraically. All right, so this is just reminding you that this C right here means 100. So this answer is just simply 100x. because the number of cubic feet is this other CF. So the C in front's 100, so it's 100 times of what he used, or 100x. Okay, example 2 says Janet works for a utility company and is reading the Savitz's household electric meter, and it's asking, what is the meter reading? All right, so this dial here, the first one, is going counterclockwise in this direction. 0 to 1 is this way. It is less than 1, so that would count as still 0. This one is reading going this direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this right here tells us that it's greater than 9, but less than 0. So we're going to use 9, or less than 10. And when it gets to that 0, we push this over to 1. So in other words, what's happening here is this is the ones, and this is the tens, and this is the hundreds, thousands, 10,000s. So if this goes to 1, 2, 3, 4, 5, if this only went to 5, and this was its first rotation, it would push this needle halfway between 0 and 1, because 0.5 is half of 10. And then if it kept going 6, 7, 8, 9 back to 0, when it hits 0, this dial here would be at 1. And when this goes to 2, 3, 4, 5, 6, 7, 8, 9, 0, when this makes a full rotation, it counts as 1 on this dial. When this dial makes a full rotation, it counts as 1 on this one, and so on and so on. So let's start at this end over here. And this one is going this direction, 0, 1, 2. It's between 1 and 2. It has not reached 2 yet, so we're going to call that 1. This one is going this direction, and it got past 5, but did not reach 6. So you only count the one it goes beyond. And then this dial is going this direction, and it got past 5, but it did not make it to 6. So here is the reading of this. This was greater than 9, less than 10. This one is greater than 0, but less than 1. So we don't round up to 1. All right, so the reading is 9,551. And that is kilowatt hours. So you do lowercase k and then capital WH, kilowatt hours. Actually, the H is lowercase as well. 9,551 kilowatt hours. Okay, so now it's your turn. Hopefully you tried this before watching this video portion. So in this one, I'm going over 1, 2, 3, 4, 5, 6. This is greater than 9, but less than 10. So I'm going to put 9. This one's between 5 and 6. So you round down. Between 3 and 4, round down. Between 3 and 4, round down. So this is 3,359 kilowatt hours. Okay. Okay, example 3 says a certain electric mixer requires 125 watts. How much would it cost to run the mixer for a total of 90 minutes? Okay, so we have 125 watts, 90 minutes, 10 cents per kilowatt hour. The first thing we want to focus on is minutes. We want to convert minutes to hours. So 90 minutes equals 90 divided by 60, 90 minutes divided by, actually it'd be 90 60ths of an hour. Which equals, and 6 goes into 9 once, with a remainder of 3. 6 goes into 35 times, so it's 1.5 hours. Just showing all my work here. It's obvious, 90 minutes is an hour and a half, 1.5 hours. So then it says to find the watt hour. So we have 125 watts for this length of time. So we're going to take that 125 watts and multiply it by 1.5 hours. And that is going to equal 125 is times the 1 is 125, and a half of 125 is, let's see, 6. Let me see. it would become, let's see, well, let's just use the calculator. I haven't gotten this out yet. Trying to do it without, but don't want to make a mistake, so let's do this. 125 times 1.5, and that would become 187.50. So 187.5 watt hours. Okay, that's watt hours. Right. Watts times hours equals watt hours. Okay, and then we need to find the kilowatt hours. So in order to find kilowatt hours, you take the 187.5, and kilo means 1,000, so you divide by 1,000, and that would move the decimal 3 places to the left, so it would be 0.1875 kilowatt hours. Okay, so now we found the kilowatt hours. And now it says it costs 10 cents per, that means to multiply, kilowatt hour. So now we're going to take this value here and multiply it by 10 cents, which is 0.1. Okay, and then all that is going to do is give us 1,875, and it's going to move the decimal 1 place to the left. And so now it's 0.01875. So the mixer cost, and that's a penny, just under 2 cents. Okay, so that'd be an approximation of 1.9 cents to run this mixer for an hour and a half. All right, and now check your understanding. An appliance uses W watts. If you run it for M minutes, and the cost of kilowatt hour is C, express the cost running the appliance for M minutes algebraically. So remember what we're going to do here is, what did we do up here? Kilowatt hour, cost per kilowatt hour, we multiplied it at the end by that. So we're going to say C times, and if we put this all together, it is going to be divided by 1,000. That's, I'm working backwards here. So this 10 cents being multiplied is my cost C. 1,000 gets us from kilowatt hours to watt hours. And how did we get watt hours? Watts times hour. So if you run it M minutes times watts, you take W times M, but then we had to divide that by 60 to get hours. Okay, so the answer to this, and you probably want to put this in parentheses because you're dividing the whole thing by 1,000. So it would be the cost times watts times minutes divided by 60, which gives you watt hours, and divide that by 1,000 to get kilowatt hours. Multiply that by 10 cents in this case, that was up here, or the cost, whatever the cost is per kilowatt hour, and you would get the price to run that. Okay, example 4 says, depending on the climate, utility usage can vary according to the seasons. Electric bills can be higher in the summer due to air conditioning use, which run off of electricity, and gas and oil usage can be higher in the winter due to heating needs if you don't have electric heat. For this reason, some utility companies offer balanced billing. Okay, so there's the key word in this problem, balanced billing, new term. This evens out the monthly cost of utilities to make the homeowner's payments predictable. Okay, so in other words, what they're saying is if you spend $200 a month on electricity in June, July, and August because you're using air conditioning, and then your electric bill decreases because you're no longer using the AC, and then you only have $20 or $30 a month payments. In order to avoid those big, huge payments in the summer, you could do a cost averaging and average out your whole year's bills and divide that by 12, and then that would give you a stable monthly amount so that you aren't getting hit really hard with a large bill in the summer, and vice versa with gas or fuel oil in the winter. Okay, so anyway, it evens out the monthly cost of utilities to make homeowners' payments predictable. Last year, the Ross family spent $3,336 for electricity. They are opting to use balance billing for the next year. What will their monthly payment be? So in order to answer this question, it's very simple. All you need to do is take their total bill for the year, $3,336 and divide that by 12. Okay, so put that in my calculator and I got an average of $278. So the Ross's monthly payments then would be $278 a month rather than smaller bills when they aren't using the electricity and a huge bill in the summer months when they are. Okay, evening out to $278 a month. Okay, now the check your understanding says 2 years ago, the Halloran family used Y dollars of electricity. So let's highlight the givens. They used Y dollars of electricity. Last year, they used balance billing. During the last year, they used X dollars of electricity and their balance billing payments were not enough to pay for their electric usage. They had to pay the difference at the end of the year, express algebraically the amount they owed to the utility company. So think about what they're saying here. What they're saying is, 2 years ago, they used Y dollars of electricity. So this is 2022 as I'm making this video. So let's say 2020, they used Y dollars of electricity, okay? So then they said, okay, well, if we use Y dollars of electricity and we divide that by 12, that's how much we're going to use every month or pay every month in 2021. But they used X dollars of electricity in 2021 and their balance billing payments were not enough. They had to pay the difference at the end of the year, express algebraically the amount they owed to the utility company. So if you divided it evenly and came up short, what you're really doing is you're taking the amount they used in 2021 total minus the amount they used in 2020 total, because they paid Y over 12 amount. So the difference was X minus Y for the whole year. And this is the answer right here. So in other words, if they used, let's make it simple. I'll just give you an example. In 2020, let's say they used $1,200 and you divide that by 12, that'd be $100 a month. So come 2021, you pay $1,200, 100 a month times 12 months, but you used $1,400 worth of electricity that year. You take the 1,400 minus the 1,200 and you would owe the company $200, which is just simply X minus Y. Okay, example 5 says energy saving appliances often pay for themselves. This means that the savings in energy usage can equal or offset the cost of the item after a certain number of years. The Thompson's old water heater cost them $455 per year to run. Okay, so let me highlight that. $455 per year to run old water heater. The new one they purchased for $1,240 will save them 31% annually in energy costs to run it. How many years will it pay for itself? Okay, so what we want to do is we want to know what 31% of the yearly the cost it is to run it for a year. So you take $455 and you multiply that by 31%, which is 0.31. So let me get my calculator and I take 455 times 0.31. And that is $141.05. Okay, so that's their annual savings by buying this water heater. They're saving $141.05 annually in electric bills. Okay, their new one cost $1,240. So if it costs $1,240 and you want to know how many years it's going to take, then you take that total cost minus the annual cost, which is $141.05, and that will determine how many years it will take to pay for it. So $1,240 divided by $141.05 per year would equal 8.79 years. Okay, so if you really wanted to get technical here, you would say, well, what is 365 times 0.7912? Okay, so it's 365 days in a year. That'd be 288 days divided by 30 approximately per month. So sometime halfway through September of the 9th year, you would break even, and the new water heater would have paid for itself. 8.79 years. Okay. Now it says an old dishwasher costs $R to run a year. It is replaced by a new energy efficient dishwasher that costs $C but saves P% per year in energy usage. Okay, so what are we going to do here? We're going to take the cost, total cost in dollars. That's this up here, 1,240. Okay, let me keep the other example up here. So if you, usually when they ask what an algebraic expression is, it's buried in your answer to the example. So if you label this up, you'll see what it is. So 1,240, if you look up here, well, that is the new purchase price. So that's the cost. So this is our C right here. So it's going to be C divided by something. Well, how did I get the 141.05? Well, it was the price, cost to run it per year times the percent saved. So it's replaced by new energy that costs C dollars. It costs R dollars to run. So R dollars to run, 455 to run. This is my R, and this is my P or percent. So you multiply R times P, which gave us this, our denominator. And this is the cost, $1,240. So you take the cost and you divide it by R times P. Okay, but remember it's a percentage, so we need to divide that by 100. Okay, so let me just put this in parentheses to make it clearer. So the cost of the new machine divided by R, which is the cost it is to run, times the percent, and since percent's out of 100, you divide by 100, and that would equal years. Okay, so there is our algebraic equation. All righty, example 6. Michael purchased a desktop computer with a monitor. It cost $2,500. Michael always leaves them both in power up mode. On average, his make and model costs a total of $96 per year to run constantly. What is the average yearly cost to own and operate this computer system at the end of 5 years? So average yearly cost after 5 years. Okay, so what are we going to do? We're going to make this a function notation. So cost with respect to x, where x is number of years owned and operated. So C of x is going to equal the cost of the computer and monitor, which is a constant, $2,500. And we're going to add that to $96 per year times x. So then to solve this, we want to know what C of 5 is, 5 years. So that's going to be $2,500 plus 96 times 5. So C of 5, okay, cost for 5 years is going to equal $2,500 plus 6 times 5 is 30, 9 times 5 is 45, and 3 is 48, so $480. So C of 5 is going to equal 0 plus 0, 0, 8 plus 0, 8, 4 plus 5, 9, and then 2. So it's going to cost $2,980 to run it for 1 year. Okay, so once I find that, now I want to take that C of 5 and divide it by 5 to see what it costs per year. So then I'm just going to simply divide both of these. Oh no, I can't divide that by 5. That's just function notation. Divide this by 5, and that will give us per year. So 5 goes into 29 5 times, with a remainder of 4. 5 goes into 48 9 times, with a remainder of 3. And 5 goes into 36 times. So on average, it will be $596 per year. Righty? Okay, check your understanding. Cheetah purchased a hot water heater. So let me just say something about that right there. Everybody calls these hot water heaters. Well, if you have hot water, why would you heat it? Isn't it simply a water heater? Anyway, food for thought. Cheetah purchased a hot water heater for her home for $580. It costs $120 to have it installed. The energy information card that came with the purchase indicates that this make and model of hot water heater will use approximately $620 per year in electricity. So it costs $580, $120 to install it. Set up an average cost rational function for this purchase. Identify the variable. What is the average yearly cost for 8 years of usage? So average, we'll say A of X equals. And we're going to take 580 plus 120. So if I do this off to the side, cost of the machine, $120 to install it. And it's going to be $700, including installation. So that is going to be the cost, plus how much it costs to run it, which is $620 per year, where X is number of years. And then we're going to divide that by what? So Cheetah purchased a hot water heater for her home, $700 to have it installed. The energy information card that came with it indicates that it makes a model. Hot water heater uses approximately $620 per year in electricity. Set up an average cost rational function for this purchase. Identify the variable. What is the average yearly cost after 8 years of usage? Okay, so it would be divided by X, which is our number of years. So when I plug it in, I would have A of 8 equals $700 machine plus installation plus 620 times 8 number of years divided by 8 will give us our average over 8 years. And that would be 700 plus 8 times 0 is 0, 8 times 2 is 16, carry the 1, 48 and 1 is 49. So it's $4,960 to run it over the 8-year period. And if we average in the cost of the machine, oops, what am I doing here? If we average in the cost of the machine and the installation, we'd get $4,960 plus 700, which is $5,660 divided by 8. And 8 goes into 56 7 times with no remainder. 8 will not go into 6. 7 times 8 is 56. The remainder of 4. It'd be $707.50 to run the machine 8 years. On average, on average per year. Okay.